Dispersion, which is also called variability, scatter, or spread, is the extent to which the data distribution is stretched or squeezed. The common measures of dispersion are standard deviation and variance, and if you are at a university or college, you may have heard about the bell curve, which looks like this. And you will often hear, this is within 1 standard deviation of the mean, or within 2 standard deviations of the mean. So let's see what that means. Let's look at the age of an instructor. Let's say the average age is 52. This means that the individual ages may differ. Some may be 48, or maybe 55, or 75. So the average age is an estimate, but what we also need is an estimate for the dispersion in the dataset. The other thing to note is the range in our dataset. For example, the difference of the range is from a minimum of 29 years of age to a maximum of 73 years, and this to you refers to a distance, or the difference between the minimum and the maximum. Unlike the difference between population and sample mean, the difference between a variance for the population and a sample is that when you compute the population variance, denoted as sigma squared, you divide it by the total number of observations. These are the deviations between observation and the mean squared, then added, and then divided by the total number of observations. For sample variance, which is denoted as s squared, you divide it by n minus 1. The purpose of using n minus 1 is so that our estimate is unbiased in the long run. That means that if we take a second sample, we'll get a different value of s squared. If we take a third sample, we'll get a third value of s squared, and so on. We use n minus 1 so that the average of all these values of s squared is equal to sigma squared. We usually talk about squares called standard deviation rather than the variance. Standard deviation is essentially the square root of the variance, or the variances in square units. So it's good to use the standard deviation because it's exactly the same units as the variable. The standard deviation of age will also be measured in years rather than years squared. Here you see that we just took the square root of variance, and this becomes standard deviation. We will return to our dataset and we'll look at the variables that we computed before. You can see that the standard deviation for beauty, evaluation scores, and age were computed with the descriptive statistics using the describe function in Python. Let me explain why mean and standard deviation have to go hand in hand. I will use the example from basketball about the 2 giants, Michael Jordan and Wilt Chamberlain, who preceded Michael Jordan. Now, if you consider their average score per game, you would notice that they didn't differ much. Their average was around 30 points for both Jordan and Chamberlain. However, when you look at the standard deviation of their performance, Jordan was around 4.76 compared to Chamberlain, who was at around 10.59. If you were to plot this distribution to see Michael Jordan's scores using the mean and standard deviation, assuming that their scores are normally distributed, you would notice even though both players had around the same mean, the tighter distribution for Jordan suggests that he was more consistent in his performance than Chamberlain. The main takeaway is that average will only paint a partial picture. If you really want to understand the complete picture about a variable or data set, it is important to compute both the average and the standard deviation to get insights on what the data is telling us. So a mean with a standard deviation means something more useful than the mean by itself.